Before we explore the solution, let's understand the problem it solves. Picture the old way of releasing an app, a stressful, all-hands-on-deck event filled with manual steps, last-minute bug discoveries, and the constant fear that something might break. This manual process is slow, error-prone, and unsustainable.
This is where CI/CD provides a transformative solution. It stands for continuous integration and continuous delivery. At its heart, CI/CD is a philosophy and a set of practices enabled by automation that creates a reliable and repeatable pipeline to get your app from a developer's keyboard to your user's hands.
While often used together, it's crucial to understand the distinct roles of CI and CD. Continuous integration is about frequently merging and testing code. Continuous delivery is about ensuring every validated change is always ready to be released. And a step further, continuous deployment automatically releases it. Our journey through the pipeline begins with a foundational practice, version control. Every change to the app, from a tiny bug fix to a major new feature, is tracked in a shared code repository using a system like Git. This ensures every change is recorded and serves as the single source of truth for the entire team. With our code managed in a repository, the automation can begin. The entire CI/CD pipeline is ignited by a single event, a trigger. Most commonly, this is a git push command. When a developer pushes their new code to the repository, it sends a signal or webhook to our CI/CD server telling it to wake up and get to work. Once triggered, the CI server, the brain of our operation, takes over. This server can be a cloud service like GitHub Actions, Bitrise, or a self-hosted one like Jenkins. Its first job is to fetch the latest code from the repository and prepare a clean, temporary environment to build and test the app. With the code ready, the first major action is the build or compile step. The CI server uses platform-specific tools to turn the human-readable source code into a machine-readable application package. For iOS, it uses Xcode's tools to compile, and for Android, it typically uses Gradle. Immediately after a successful build, the first line of defense in our quality gate kicks in: automated unit tests. These are small, incredibly fast tests that verify individual pieces of code, like a single function or class, work as expected in isolation. They provide the quickest feedback on whether a change broke existing logic. While unit tests are essential, they don't tell the whole story. The next layer of testing is integration tests. These tests verify that different parts of your app work correctly together. For example, does the login screen successfully communicate with the user authentication service? This ensures the plumbing of your app is connected properly. All this happens in minutes. The developer who pushed the code now receives automatic feedback. If the build or any test failed, they get an instant notification, often in Slack or email, with logs to help them fix the issue immediately. This rapid feedback loop is the core magic of continuous integration, preventing bugs from ever getting far. A successful CI run gives us a validated, tested build. This marks the transition to the next phase, continuous delivery. The goal of CD is to take this validated code and prepare it for release. This involves several crucial steps, starting with one of the most unique challenges in mobile development: code signing. Before an app can be installed on a user's phone, it must be digitally signed. This signature verifies the identity of the developer and ensures the app hasn't been tampered with. For iOS, this involves certificates and provisioning profiles from Apple, while Android uses a key store file. It's a critical security measure for both platforms. Handling these sensitive signing files manually is risky and inefficient. In a CI/CD pipeline, this process is automated. The signing certificates and keys are stored securely in an encrypted vault. During the build process, the CI server is granted temporary, secure access to these secrets to sign the application automatically. Once built and signed, the final, distributable files are generated. These are called artifacts. For iOS, this is the .ipa file, and for Android, it's in .abk or .apk file. The pipeline versions these artifacts, e.g. app v1.5.2-build 345, and stores them in a secure repository, creating a permanent record of every successful build. With a signed artifact ready, we can now perform tests that were impossible before, like UI tests. These automated scripts interact with your app's user interface, mimicking real user actions, tapping buttons, swiping through screens, and filling out forms. They run on simulators or real devices to catch visual bugs and workflow issues. After passing all automated checks, it's time for human feedback. The pipeline automatically distributes the app to internal teams. It uploads the iOS build to TestFlight and the Android build to Firebase app distribution, then sends a notification to your quality assurance, QA, and stakeholders that a new version is ready for review. Once the internal team gives their approval, the feedback loop can be widened. The pipeline can then be configured to automatically push the build to a group of external beta testers. This provides invaluable feedback from real users on their own devices before the app is released to the general public. This brings us to a key concept in continuous delivery, the manual gate. Even though every step so far is automated, the final decision to release to the public is often a deliberate business choice. The pipeline brings the fully tested, production-ready app to a one-click release button, waiting for a product manager to give the final go-ahead. When that release button is pushed, the final stage of automation begins. This isn't just about uploading the app file. Modern pipelines can also automate the submission metadata. This includes updating the What's New release notes, uploading new screenshots, and setting other store listing details, ensuring consistency and saving hours of manual work. Finally, the pipeline executes the submission. Using tools like Fastlane, it communicates directly with App Store Connect for iOS and the Google Play Console for Android. It uploads the artifact and all its metadata, navigates the submission process, and sends the app for review, turning a complex, multi-step manual process into a single automated command. But the release doesn't have to be a big bang. Modern CD practices often include phased rollouts, especially on Android. The pipeline can be configured to release the new version to just 1% of users initially. The team can then monitor for crashes and issues before automatically increasing the rollout to 10%, 50%, and finally 100%, minimizing risk. So let's recap the entire journey. We've seen how a single Git push triggers a chain reaction. The code is built, unit and integration tests are run, the app is signed, artifacts are stored, UI tests are performed, and the build is sent to testers. Finally, with a single click, it's submitted to the app stores for the world to see. To build this pipeline, you'll need the right tools. The mobile CI/CD ecosystem is rich. You have general-purpose platforms like GitHub Actions and GitLab CI that are highly customizable. You also have mobile-specific services like Bitrise that offer pre-built steps for common tasks like code signing, making setup much faster. Now that you understand the process, let's focus on the rewards. The most immediate benefit is a dramatic increase in speed and release frequency. By automating dozens of manual tasks, what used to take days of coordinated effort can now be done multiple times a day. This allows you to deliver value to your users faster than ever before. Speed is nothing without stability. CI/CD embeds quality checks at every stage of the pipeline. By running thousands of automated tests on every change, you create a powerful quality gate that catches bugs and regressions instantly. This leads to more stable builds, fewer production incidents, and a higher quality app for your users. Finally, CI/CD profoundly improves your team's efficiency and focus. It frees your most valuable resource, your developers, from the tedious, repetitive, and error-prone work of manual releases. Instead of managing builds, they can focus on what they do best: designing, building, and innovating new features for your app. Of course, implementing this isn't without its challenges. The initial setup can be complex and time-consuming. It requires knowledge of scripting, build tools, and secure secret management. Furthermore, the pipeline itself requires ongoing maintenance and monitoring to keep it running smoothly and efficiently. Another persistent challenge is managing flaky tests, tests that pass sometimes and fail others without any code changes. These can erode trust in the pipeline. Additionally, as build times grow with your app's complexity, you must invest in optimizations like caching and parallelization to keep the feedback loop fast. In conclusion, despite the initial investment, a robust mobile CI/CD pipeline is no longer a luxury. It's the standard for professional mobile development. It fundamentally transforms how you build, test, and release software, empowering your team to deliver better apps faster and with greater confidence than ever before.